Hello everybody, welcome to another stream. How we doing? So last stream, I was like, PBR, completed it. That was me just getting, being like, you know, we're near the end, basically. We're near the end. So hopefully this stream, we're gonna knock all the little things off. But you know, things are looking good. This is plasticky looking spheres, and you can see the reflections, and they look much nicer now. They don't go blocky. This is a very perfect mirror looking one. When you increase the roughness, yeah, we should probably start having some form of roughness because it just gets too dim. That there. But as we increase the roughness, these now blur out really nice. So that's really cool. So that's the improvement we made last time. Now, I think our metals though. Hey there, glorious sir. Master Agent, how you doing? And Alex, welcome guys. Welcome back. How you been? So, the metals though, I feel like these guys, there's just something where I'm thinking they're not looking right, like, I don't know. So I think we're missing two things, right? We not including the geometry shadowing function as part. So we need to do the BRDF. We need to for the pre-filter map, or the radiance map, as some people call it. So that's for the specular part of this reflection. So it's the perfect mirror bit. I think that needs to use the BRDF for the geometry shadowing function. Because we're not doing this, basically, this geometry shadowing for that specular. But except for it's for the reflection. This is the one for the light. So you're seeing it in terms of the light direction. Yeah, this is the one from the light direction. So we need to do this one for the specular map, I think. But yeah, so it should cause a change. Oh, not the specular map, the radiance map, the specular radiance map thing. Yeah, sending the radiator tunnel, exactly. Getting close. Getting close. So there's also a shimmering problem. I spoke with someone at work, and they gave me a link to a blog, and they were saying, so we get shimmering. Let's increase our light for a bit. So see here, if we move those buildings, they shimmer. Now he was saying it could be because it's perfectly smooth that I'm getting shimmering. I should really have like a minimum roughness or something. To make sure I'm not sampling from the complete. I should never be sampling from the perfect mirror, specular, or the pre-filter map. This one. I should never be sampling from this perfect mirror, specular map. It should always be the in-between MIP of 0 and 1 at the minimum, right? So this is where it's slightly more blurrier, rougher, and rougher. And there's obviously just some in between. So what we need to do, yes, it's already kind of fixed it, I guess, just making it a little bit rougher. But there's also another technique we could apply, where I don't quite understand it yet, but effectively when we create our pre-filter map, as people call it, I'm not sure of the name. I think someone called it a pre-filter map and everyone's just gone along with the name. Some people call it a radiance map, and then the diffuse one an irradiance map. But I think they're all irradiance. I'm not quite sure. But yeah, apparently you can, when you sample that, when you drawing time. Feels like the thing. Feels like a thing Mitmaps was created to solve. Incorporate F-width into the LED selection. Yes, so that's the way that I originally thought I should solve it, but I'm doing ray tracing, so I don't really have a derivative. So I was trying to calculate it manually, and I was thinking I can use the quad intrinsics and just basically implement F-width on compute shaders, but then the rays could be at different points. Like if you're ray tracing through a BVH, the rays on a 2x2 could be at different BVHs or whatever, or different spheres technically at the same time when they, when they run in the same SIMD lane. So your F width is going to be wrong, but they could end up hitting the same thing. So that's out the picture. But it could just be a hack because the guy who I spoke to said that he doesn't have that problem in his one, but he clamps his roughness to 0.1 and above, right? 0.1 to 1.0, obviously. So yeah, I'm going to try out these techniques and hopefully we can. Yeah, so there's this. I'll read what this says here, but yeah, apparently we when we sample the oh okay, I was going to draw it. So we calculate so this is a cube map, and we have we're trying to render this face of that pre-filter map, right? This face at the top. So you have your point, and basically you're trying to cache say if like, I don't know, we're looking from this angle and then we get a reflected ray and it goes up that way in the scene, right? So directly up. We're going to encode, hey, if we shoot a ray directly up in the scene into this pixel, we're going to encode effectively a bunch of rays, say if it's like a little bit rough. I guess this is like roughness 0.5 maybe. So it's like this big. We're going to grab the cube map of the environment and grab all these pixels along here, right? And then encode the average of those colors into that pixel. So next time when we just we get a reflected ray that hits the ceiling, we can just take that average from the pre-filter map. And that's why we get that sort of blurrier image. So apparently when you do the samples into the cube map, there's a little trick you can do which improves something. I'll drop a link to this article if people are interested. Hey, Chandu, how's it going? How's it going? We can improve the filter rate of convergence by filtering our samples as well, right? So maybe this improves the quality, right, with the same number of samples. The idea is described in detail in the GPU Gems article. If people don't know about GPU Gems, you should take a look at this. Like, there's all 3 books online. You can skim through all the titles and be like, oh, and see like, oh, this is interesting, and then just go and sort of read about that. There's tons of good stuff here. There's like, again, there's 3 books worth, and it's all for free. And there's some interesting things. Check those out there. So, which this guy will briefly summarize. When using our important sampling routine, we can evaluate the PDF, the probability distribution function value for the sample. And if it's small, then this corresponds to a direction we sample infrequently, right? To improve convergence, we can consider this equivalent to be sampling a larger solid angle on our hemisphere. The inverse is also true. Samples with a higher probability distribution function value will correspond to smaller solid angles. But how do we sample a larger and smaller solid angle in the environment without having to integrate? The solution is to approximate this by sampling the MIP chain of our environment map. So this is the thing that wasn't in the Learn OpenGL tutorial that could probably improve our quality a bit. So let's just throw this in here. So when we generate that pre-filter map, I probably want to change that name when we do our cleanup episode. But for now, I'm going to still call that pre-filter map. It's the specular environment map, if you will. Yeah, and I realized that the importance sampling thing is important, so I'm getting rid of that other code. Right, so ours is pretty simple. We just need to add some extra maths in here. Yeah. Good old copy paste. Right. DGGX. Wait, where's the DGGX? Right, let's go and get that. That sounds interesting. We're not using important sampling though, right? No, we are. Yeah, so last stream, I think you missed last stream. So the stream before, where the one you was in, we did the irradiance map. This one is the diffuse. So it's where you have the hemisphere and you blast. So you're trying to cache for when the surface normal goes directly up. And you're caching for that. You're caching in that pixel there. So you ray trace the environment map and then average all of those guys and store that in the irradiance map. And that one is the diffuse. Whereas there's another one called the pre-filter map, which is for specular. So that is when you have like when you have reflected rays, basically. So it's another image. It is basically a blurrier cube map, whereas the diffuse map is like a Minecraft painting, if you will. I think that's right. Wait, maybe my pre-fill map is too high a res. We can double check this. No, it's got to be higher res. Yeah. Right, so we can get this DGGX thing. I guess it's just all maths, isn't it? Excuse me. Hey, Sleepy Mushroom, how's it going? Right, have I got one of these? I think I've got a DGGX. Linear roughness. This looks familiar. GGX Trowbridge. NH half vector. Yeah, this is it, isn't it? 1 minus. Yeah, it's basically very similar. A is. Let's see. It's kind of similar, but yeah, it's this function basically. So float n dot h, normal dot half direction, and we do that here. Right. So yeah, that's what we need. So where do they compute the n dot h? N dot h is v dot h. Maybe I should change my functions to just have it passed in. Oh, v dot h. Sorry, what is it want in? Right, okay. N dot h. So yeah, I think we need to change how this works. We'll pass in instead. We'll pass in the dot product instead. N dot h. So whenever we do this now, have it passed in. So we'll have a lot of these pre-calculated somewhere, I reckon, just pass it in via a big structure. But for now, let's do this. All right, so back to here. So the roughness is alpha, isn't it? Oh, no, roughness. Shoot, that needs to pass in alpha. My debugging thing's a bit wrong. Alpha, which is roughness squared. Okay, they're corrected now. Right, and then it's alpha. Or I guess BC roughness then. Hey, look, Mom, no hands, how's it going? The share in the number is what you did. Oh, interesting. I might have seen it because I'm pretty glued to YouTube, but have a gander. I got a consent? Okay, maybe not. Oh yeah, I've seen this. I've watched some of this guy's stuff. Yes, these were interesting. Yeah, I think he lost me on some of them. I think at image baseline, I think he lost me. But yeah, I watched a lot of these though. Yeah, they're quite good, yes. Um, Hungry but good. Hope you're doing well, mate. Yeah, yeah, yeah. Yeah, I'm not too bad. Quite a busy day today. The boy was not being. It was his first day first full day at nursery, and he was also tired, so he wasn't too happy. So it was giving them a bit of grief. So I had to go and pick him up kind of early and take him around the grandma's basically. So yeah, other than that, not doing bad. Not doing bad. Yeah, give me that burger. Yeah, you should eat that burger. Right, MIP level. Right. So we should be able to throw this MIP level into that slot right there. So yeah, this should improve the quality. So we're not going to be able to toggle this because we launched this shader at boot once and it takes its sweet time. So we should probably have this as some toggle, and we use our lovely screenshot tool, and we should be able to compare the difference. Yeah, I don't know. Yeah, would have to. Yeah, I got an idea. So we can else. So I think we can go into the graphics. Love me some graphics. And we're going to hard code this roughness, or we're going to initialize it to something where it's like, this is what we'll take the screenshot with, which would be 0.25. So this shader's not compiling, it's crying. Right, turns out this is declared after. So we should really move these boys and girls around. Let's yoink these two shaders out. Coke torrents, calculate BRDF. Surface color. Yeah. There we go. Whack them in there. So, sample counts. Right, let's try to do like a C++ constructor thingy. Get that out of there. Image size. Alright, let's take a gander at the blog article again. Image size is for, I guess it's meant to be square. Yeah, I guess it's just a square image. And then MIPS, okay, so it's the full resolution. So that for us is known as the BC DST DIM. Wait a minute. Oh, no. Environment map dim. Yeah. Alright. Bit of log2. And there we go. So we're going to take some lovely screenshots and see how this improves the sampling. Forward declare them, like the function. Yeah, I could have forward declared it, I guess. That's another way of doing it. I don't usually like forward declaring in random places because it's just messy. And then I have to change it in two places. I'd rather just have it in an order. And I only forward declare in header files. But this code is messy. And when I clean it up, it would just be nice not to track around forward declarations. So the reason why I type def strut is C, right? In C, Like C++, you can just do that. C, you have to do this. You can do it many ways. You can also type def strut this, and that also does the same thing. But in C, if you just do that, every time you want to use this, you have to say strut depth, and then you put in your variable name afterwards. You have to put the strut keyword before. So that's why you type def, so you don't have to the strut keyword. You never do this in C. Well, you wasn't using C then. You was using C++. Because you do have to do it in C. Right. So we got to. I don't know what I want to find. Right. Here's the best thing to do. Take a screenshot of the texture viewer. So if we find the pre-filter map, and then let's take a screenshot of this and compare it. So F12, I've taken a screenshot. Now we're going to, I don't know if the highest resolution is going to, but do a change, but anyway. Now I'm going to go to texture viewer. So there's our last one, where I put that in screenshots. Now we pre-filter map. Now I'm going to do Alt F12. That puts it in this one. Right, so I don't really see any difference there. Kind of looks like the same. Let's maybe because I've just got so many samples that we're just not seeing any improvement. Let's go to, maybe it's just better the rougher it gets or something, I don't know. Let's compare like a, I wonder, maybe we would have to do less samples. So it did say it would improve our rate of convergence for a certain number of samples, but maybe we've just got so many samples that this is the best it kind of gets. I don't know. So let's take a screenshot here of that. And then let's enable this mode. And we'll do it again. So bring up the texture viewer. And we use the pre-filter map, MIP2, I believe it was. Or was it MIP1? It's definitely MIP2. Right, and then we'll do an Alt F12. So now we should be able to compare the two images in here. Oh, why are they slightly different zoom? Shoot, they are. Alright. Yeah, the slightly different zooms is probably not a fair comparison. Yeah, it's probably not a fair comparison, they're not the same zoom. Right, I don't know. I'm just gonna leave that code in and leave it on. But I guess we can play around with it in the future by turning the number of samples down or whatever. Listens bug ahead. No, I think this is this is the new Stone Rebel album. And hey there, Hostman, welcome back. By the way, I had another interview today at another place while I'm waiting for a reply on the submission earlier this week. Went well on the interview today. Over test tomorrow. Awesome. Remember to make sure you tell them other people are interested in you. Number one rule when you're interviewing. Yeah, it helps a lot because if they like you, they'll fast track you, and it also make them seem like, wow, this person's other people are interested in this guy. Maybe I should be. Well, they don't think that, but it makes them feel that way. But yeah, that's really good to hear. I'm glad you've got another potential opportunity. That's really cool. Is it like remote, or would you have to move to the location, or is it nearby? Um, Chandu, no. Well, if it's good news, that's cool. I'm happy for you, my friend. Yeah, it came up by chance. It sounded like it got his competitive side. It got his competitive side going, honestly. Huh? You're a web dev, not a graphics programmer. That's cool. Yeah, yeah, I think these are looking good. What we should probably do is clamp our roughness, because it's causing us problems. One, they sort of like flicker a bit like that. Yeah, so we should probably clamp our roughness to be something a little bit more. I don't know what this number is right now. I'll find a way to... Because it's sort of flickering as well. So we need to make sure that in our normal distribution function... Oh, what is that? Right, let's look for GGX Trowbridge. It's not that one. Schlick. Oh, no, it's the Trowbridge. Right. Oh. So example 0.01. Maybe that's still not enough. But yeah, that specular highlight. Maybe we need another 0 in there. Wait, it's squared. Oh, wait. Ooh. Wait, but alpha's already squared. Like, alpha is roughness squared and it's squaring alpha again. Yeah, it needs to go a bit smaller. Move to location to Malmo, in that case, other side of Sweden. Same goes for Funcom as well. Just something. Sorry, Stockholm, in that case. Oh, okay, nice. Isn't it Sweden Day today? Happy Sweden Day. I think so. Got some Swedish people at work, and those guys were off today. I think they said it was Swedish Day. Sweden Day. Right, maybe it needs another 0. Maybe that's what we were. Yeah, I got rid of the square roots in the shader, but you need the square. See, that's a bit too faint there. Just a little bit more. So maybe change that to a 2. Yeah, national holiday. Sweet. Right. Not as faint anymore. So that's the minimum. Oh, it's a little bit faint though. Maybe we should say 2.5. That's cool. No, I don't think it was necessarily that joined late. It just might have been some small detail you might have missed. I think it was last stream that it happened. So I'll show you where we did it. Yeah, I don't ever want... Maybe we should say 4. It's a little bit bigger. So when we generate that pre-filter map, which I'll go over again what the pre-filter map is. Yeah, so the pre-filter map is what we're displaying in the reflection. It's in the texture viewer. This is the pre-filter map, right? Well, that's a screenshot of the pre-filter map. So as you go down the MIPS, yeah, we saw a rougher version of the environment map, which has got this nice sort of blur to it. So when we calculate that to make it work, oh, I know why it's not working. We didn't downsample the environment map, so it's not even selecting the lower. That's why it looks identical. Right, we can change that, that's fine. But yeah, so I ended up doing it here. Ah, yeah. And the formula I came up with was... Wait, is there a square root in here? Okay. The formula I came up with was basically just dividing the roughness by 2. And that made it look better, I think. Or scale the way I wanted it to scale when I drag the sliders. So it feels like a linear slider, but it's obviously not linear. Oh yeah. Those blocky Minecraft textures are still there. That's a different one. That's the irradiance map, where it's a smaller version. Yeah, these guys. Yeah, blocking Minecraft textures. So that's the diffused light. So you need a smaller texture. So I actually need to do this, something like this again. But so I deleted the code, which was dumb of me. I think it's called like downsample cube map. So we had this before. But I got rid of it because I was like, we don't need a downsample cube map anymore. So we're just going to downsample it. So the source is the current MIP, and then the downsample, the destination is the next MIP. We need DST MIPS. So it's DST dims. I guess we did divide equal to. Of myself. Oh, it's already here. And then we'll initialize it to the actual dims. Layer index. So rather than pre-filter map, it's got to be in the environment map. Oh, number of MIPS. Okay, we are going to have MIPS for this. 9 MIPS. I guess we'll do something like this. Sweet. Environment map. Oh, I've got to sort those out as well. Initialize more textures. Right, so this is the downsample cube map. shader. Rightio. So that should be all we need to do. We just need to initialize the texture views, which is a view into the environment map, cube map, for a specific MIP level. Because you can't write to individual MIP levels in shaders. You can only read from them for some reason. For some reason, there's a weird limitation, so you have to make a texture view which targets an individual MIP level. Like one of the many gripes about GPU programming is stuff like this. Right, so we need to then go and create those individual MIPs. So again, more messy code incoming. So we'll do a for range over all those. We need to make sure that we put in here the number of MIPs, environment map number of MIPs, when we initialize that texture. Then go over all the MIP levels for environment map number of MIPs, and simply initialize the texture view with a base MIP level and one MIP level after that. If it's the first one, initialize the base ID, and then make sure they're equal to each other when you set them up. Cool. That's it. So now when we do the sampling, the image should actually be different now. So we should run it in that pre-filter map. Yeah, so when we render the pre-filter map, we've got this section on now and it does this MIP level thing when it samples from the environment map. So it would be interesting to see how that works. Chandu, I wouldn't bother getting a book on GPU programming. I know there is a Vulkan book, I have bought it, but it's quite Vulkan API. I highly recommend doing that ray tracer project that I mentioned to you last time, or a couple of streams ago. That will give you a lot of insight, and then you have tons of questions. You have ideas of what to start Googling for. Right, the stream did not die. That is good. So apparently this is the better image. Let's have a look. So now our environment map. Right, this is just the environment map that we see when we miss a ray trace. It's got a full MIP chain now. Right, so this is just a downsampled image, right? It just goes blocky. But if we see our pre-filter map, this guy, oh my days, that's so much more. This is definitely different. Yeah, I don't know if this is better. We can't see a perfect reflection. Right. I think my roughness value that's going in must be too much, because this is just crazy. It definitely looks different, I can tell you that. Like when we run it now. Oh, that's interesting. But I'm not seeing that shimmer anymore. That shimmering is gone. And we're still kind of seeing a reflection, to be honest. I thought I couldn't see that building in that image. Let's make it more metally. Alright, that's interesting. Well, that definitely fixes the shimmering. I'm not sure about how. But that pre-filter map just looks like... Oh, of course. I think this is okay. Maybe. Maybe we should change the roughness value. So we are seeing a difference now. I'm still confused how this image looks. For a build menu in game, you want widget buttons, snap, react on key down. To be snappy, react on key down, right? Or you want it to be safe and release on when hovering over the button. These buttons are the actual build categories, and it's buildables within. Right. Yeah, if it's a button, then it's always on a key release. Obviously, key in, and then you have to stay hovered over it, then release. If it's a button, unless it's a toggle button where you push it in, like on a click. These are toggle buttons. So as I click it, it will change. But on buttons, they should. Yeah, they shouldn't act like that one just did. They should always be on release. I think my buttons in my UI actually don't act on release. Because I never went around and fixed it. Yeah, it turns out the Boolean wrong. But yeah, they should act on release if they're buttons. Yeah, so should we play around with that roughness value that we pass into the pre-filter map render? For the pre-filter map, when we render this roughness, let's not, wait, divided by 2. Let's divide by 4 for a minute. Oh no, but usually it's squared, isn't it? Yeah, the problem was probably the Troitz bridge one. This expects alpha to go in. Right, maybe this should be squared. Yeah. I think this needs to be alpha. That's the problem with it. I think that's the issue. Yeah, it seems like we are seeing a difference though. I don't know if this divide by 2 is now needed. Might be though. Well, we'll see. Right, so have a play with these balls. Yeah. So, metalness goes up. We're seeing a reflection. Right, see, as we got half rough, it's basically fully rough in a way. So I don't know what we want to do. I think that's why we did the divide by. Wait. I think that's why I squared. That's why I squared it or something like that. Yeah, but then if I'm square rooting it and squaring it in the shader, let's see how it changed the textures, because that's what we're trying to look for. Right, that kind of looks just the same. But this doesn't feel kind of linear now when you change the... Right, so the minimum... Yeah. So I think we had the scaling thing okay, actually. So by dividing... Yeah, so if I remove the divide, it's just going to do... No, maybe we're okay with this one. Wait, it still was... I'll do it in a minute. That's looking nice though. Hmm. But yeah, so I took rid of the divide by 2, and as you can tell, it just goes fully rough basically too quickly. And the divide by 2 means that... Should be dividing though. Alright, so look here. So metal on. Yeah, then when it's fully rough, you basically get that. That's alright. Yeah, I guess it's okay. We've definitely fixed the flickering problem. Yeah, I was hoping maybe... for it to be a little less rough on the first one. Maybe that's due to the minimum. We've put that min here. Say if we bring that down to... And now have a roughness of 0 at this point. So if we put this down to... Let's do 0, 1 again. Like a very small value. Let's see if that changes the image a bit. No, it's still kind of the same. Right, let's put it back because that fixed the little reflection, the specular reflection. Small. Hey Meeple1, how's it going? Yeah, proper epsilon values. We doing? I just got delete Mr. Still shotty. I always got to think before I do that because I sometimes write the word raid. I'm like, no, don't raid this person. No, I can't type that. What? So apparently John Carmack had a hottie debate on Twitter regarding that press thing. Wow. Pressing a button. I'm of the same mind, but I wanted to see what people actually feel. Passionate arguments against the act of pressing game UI. Huh. Yeah, the one that's really interesting to me as well is if you have like a file browser, people prefer a single click. But I don't know, double click has always been, you know, Just what you've always done, right? But some people really like the single click one. And KDE is on by default. But then if you want to select a folder, you have to hold control and then click. That's a weird one. Oh, that's epsilon. See, actually, this is a symbol for it. That's cool. Neat. Right. So what have we just done? We've fixed the shimmering in the reflections. We've also made the metals, I guess, look better. Right? So they don't look as... There's the plastics. Oh my days, this... Why is that disappearing? Did I not compile it? There we go. And I guess the metals look a bit better now because of that. That pre-filter map, the reflection map. Yeah, it looks a bit better. What else do I want to improve? There's a list. Yeah, we want to put the BRDF in the to use it alongside the pre-filter map because we are not using the geometry shadowing function like we should be. So let's go and copy and paste some more code. So we need to produce this texture basically, or something similar. So we need to pre-calculate the BRDF. Yeah. Oh, let me finish that. So this should be used in tandem with that pre-filter map when you sample it. You also need to sample this as well. And this does a similar thing where it caches in this texture. Yeah, the BRDF. So I guess let's bring this in. Although this is dumb. Should just be included in the same function. So, right, here we go. So we need to define another shader. Yeah. Right, so let's go and refactor all this. So V Smith GGX correlated. This probably is actually just identical to our other one. But I'm not going to bother changing it because it will just be, we can do that when we clean up. To do the same as Smith geometry. It's probably the same as this one here where it's Schlick-Beckmann. Or maybe it's not. So we should probably try and use the same one. But yeah. Because this looks like it's the Schlick-Beckmann function inlined by the looks of it. But right, we'll just stick with this. So integrate BRDF, we're going to copy paste this one in here. So A is what? Roughness. and then NOV normal dot view. Sweet. So just got to refactor this quickly. It's the 5th letter in the Greek alphabet. No way. I thought it just meant a very small number. That's what I found out when I Googled for 8 years ago. So it's not that, no? We're crying out loud. I have to tell my Greek friend at work that. I did not know. Oh, this is the Greek alphabet, eh? Interesting. Right, image size S targets. That needs to be passed in. Right. We need we need ourselves one of these boys. So what is the shading going to be called? So I guess it's the pre-fill map. Pre-fill BRDF. I need to do some things. Threads, helpful, 16. Uh, 16. Only 16 by 16? Alright. Right, okay. This one's going to be called the generate pre-filter BRDF. So I guess we'll change this to a different we'll change the name later on when we do cleanup of the code. So we need to have a what do we need to have? Right, I should probably stick that near there actually. So we need to have the destination texture at least. So we're going to write into a single 2D texture, I think it is. Are they, what sort of values are these? Are they HDR? Does he have the texture creation code? Just shader code. Right, don't blame him. I don't know what values these are. They're probably... Learn OpenGL did the same thing. What did they do? It's called generating the BRDF thing. It's near the end. Here it is. Right. they're using proper floating point, but it's only RG16, 2 channels. Yeah, so I guess we'll just use a full floating point right now, but we'll probably pack it. We'll probably pack them in future, which will definitely help with performance. So we need the dims. And we'll work out the rest. So that's all in there. Awesome. So image size is right. What the hell is this global invocation ID? I always forget which ones these are. Right, this one is the... is equal to the work group ID. Yeah, yes, this one is the dispatch index. +1. Hmm. Right, that'll do it. Wait, +1 though. Cool. Right. Is that really a UV though? You're never gonna get 0. I'll have a think about that. Right. So, yeah, I'm still a bit confused on that, but I guess we'll see it as we go. We just got to remember to come back to that. That's all fine. Let's change all these zeros with Fs because we don't have doubles. Oh, excuse me. That came from nowhere. Okay, so it looks like a kind of a simple shader. Right number of samples. As the dot. All right, so this should. All right, nearly done. Saturate. We don't have saturate. What is saturate? Saturate is clamp F32. Well, it's just clamp with a 0 and a 1. That comes from HLSL for all those people who are not HLSL programmers. In OpenGL, people sometimes just make the function, or in GLSL, sometimes people just make that function. So, right, I think we're nearly there. That should be. Where else is num samples thing? Huh? Oh, uint is not a thing. Right, it's my compiler not being helpful. Whoops. Roughness. parameters the wrong way around. Okay, so this requires a bit of vector maths. I think we've already done this before. Wasn't this the... There's a specific function for that, isn't that the front? No, it's not the Fresnel. Which one is it? You know, I've just seen that before. Did we use it up here? H6V. Zero. Right. Here's one I made earlier. Times by 2. Multiply H by that, sub. It doesn't norm it. Why is there no norm? Yeah, it needs to be normed. What's this? Then it computes the... Okay. Right, times 4. Divided by samples. Well, I guess we just do this, divide by num samples. Sweet. Then we just got to store it in the image. Right. That'll be something like this. 2D float to... I think we want to store it upside down, I'm not sure. Let's store it the right way up. Do we have a DST chord? We don't. Yeah, that should just be SV dispatch index XY res, I guess, as they call it. Right. So we've got to change that in the... Yeah, float 2. Sweet. No. Storage extended formats. Okay, so I need to add this to my compiler. Right, I would have thought... Right, let's hop in to HCC code base. I would have thought... image format... Right, SPIV image formats. So there's... Okay, I guess some of these are extended ones. And I think sometimes, you know, when we link the SPIV binary, I think... Yeah, we have these capability things. Now... I think... Yeah, some of them go on because of a compiler option via the command line. Others are just put in automatically, which is kind of a bad idea. So I was thinking, sometimes I was thinking, do I check if you've used it and then put it in if you've used it? And I don't think I do that at the moment, which is not really a good idea. But, problem for future Henry. What capability is it? Past Henry keeps doing this to future Henry. I see why he does it though. What do I need? Storage extended formats. But I think, you know, most hardware really supports it, so it's probably okay. 49. I put that in twice? No, that ain't right. Oh no, yeah, okay, I copy pasted it. Right, so it's 49 we need to add. What's the exact name? Storage image extended formats. Boom. And then we'll just throw that in there. Sweet. And then away we go. So we just need to quit out all of that, do a new release build. Ding. Go into the workbench. Grab the new build. Wahoo. And plop it in third party HTC. Ding. Oh wait, did I cancel that? Right. So now we should be able to resume. So it all compiles. Awesome. So now we just have to set this up CPU side. What is the size of the texture? Good question. What is the size of the texture? The lookup table. 128 texture. Okay, so well, let's just double check the Learn OpenGL one. Yeah, where is UV used? Okay, it's there. How do they compute the NOV, n.v? Right, so they do it in like a pixel shader, so it already interpolates it perfectly. Right. Yeah, I wonder if that is correct. Anyway, we'll see. I think it's a bit off. Fills it. I might be wrong. Right. So in the we need to create a new texture. Same with most things, right? New problem to solve. You need new shaders, new textures. So yeah, we need the I guess we'll call it the pre-filter BRDF texture ID. So we'll just call it that for now. So what do we need to do? Well, pre-fill BRDF texture. What is it? It's texture 2D. We also need to add a new format. This new format is going to be 3232. So it's RG basically, red green channel only. Again, we're just going to use the highest resolution one. We should really pack it down. That would get us a lot of speed gains in shaders, but we just want to get stuff up and running right now. So that is not the primary objective. Number of MIPS, 1, basically none. Number of race slices. So yeah, that's cool. That's gonna get created, all good. But we actually didn't finish adding the format. I just added it to the enum. So let's chase this boy down. So bytes per channel, sorry, per pixel. So it's half of that. So it's 8. Number of channels, 2 channels. My first 2-channel texture. Whoa, texture format. This one is the string, the long name string, short name string. Is it sample format? Yes. Is it storage format? Yes. Is it text? No. Right, so that's all of those ones. And the final one is in the Vulkan layer, where we translate it into a Vulkan texture texture format. So it's just RG32, that one. Cool. So that should be the texture getting it. Oh, closed. So we should now be able to have that texture get created, but it's going to be uninitialized because we haven't. Here it is, initialized it. So we've just got some lines for some reason. They're just in the green channel as well. Interesting. So now we need to run that shader. So where is the... We need to calculate it probably in the same place as the other ones. So let's look for okay, we'll just... So I guess we could just do it right after this one. So let's just copy all of that. Generate prefilter map BRD, prefilter BRDF. Maybe this gets reused in other places later, I'm not sure, so maybe the name will change. But we'll see. So we want a destination. That's the prefilter BRDF texture. We need a dims. So that is basically this guy here. And then we don't need anything else. So we just need some sync code. And then, so we're basically writing only to the BRDF texture. And then we just need to call the right shader. Launch across all those dims. It's a multiple of 8, so we don't need any bounds checking in the shader. Yeah, legit. So let's run that and hopefully we get the image that we're looking for. So check the texture. Sweet. That looks like the other one. Color linear. RGB linear. It's RGB. It's kind of a linear one though, not gonna lie. So we should... Where's that? I forgot to change. Yeah, it needs to be added to the color linear section. So when we view in the texture viewer, default uses the linear color, so it doesn't convert from sRGB to linear. Right, that's good. Yeah. So now we need to plug this in the shader. So again, let's go to the blog. So yeah, I did. Right, so we need to do a lookup. A little bit based on the roughness as well. So when we calculate our color, calculate sphere color. No. Where is it? Surface color. Here's that new one. Right. For some reason, it's in calculate BRDF. This is wrong. It needs to be refactored. I think we're going to do this next after we finish with this one, because it's all crammed into one function. Kind of wrong. Wait. Yeah, the BLDF should only be for the lights. The reflect should be separate, but I'm just adding it to the specular, and then it's just getting added to diffuse and passed out. So it's correct in terms of what's happening. It's incorrect in terms of code structure. So yeah, what we need is to sample out those two values. So BRDF. So sample, I guess at a MIP level. There's no MIPS, but you have to do it in compute shaders. Texture, 2D, right. So this is going to be the pre-filter BRDF texture. So apparently, the way we sample that is with a right, n.v. Where's our n.v? Right, let's get an n.v in here. There's the n, there's the v. So we need a sampler, it's probably a clamp linear. N dot v, then a bit of roughness. So that'd be material roughness. Noise. So we take that BRDF. So we should probably have a little toggle box, a checkbox, so we can see this thing turn on and off to see how it contributes to the image. But so the Fresnel, I haven't done the Fresnel roughness. I haven't done that one. We probably should look into that as well. But yes, it's the result of the Fresnel. Alright, where's the Fresnel Schlick roughness one? Let's rob that. Do an example here. Fresnel. Roughness dependent, here it is. So I think we need to get that in there as well. For now, n.v. Yeah, maybe we should just pass in n.v. Well, that's half. Yeah, it actually really depends on the. Right, let's just keep them separate for now, a bit different, that's fine. And then float roughness. F0, yeah. So, hang on a minute. And then it's like maxing. And subbing. Right, that's FR. Then we need to POW. And then we need to scale this vector by this scalar. And then we need to add. Those two together there. And then, so you're getting a. So what is that? Roughness dependent for now. Where's the? Yeah, I guess that's the return. Wait, what's going on here? So it's just scale them. Wait, what is FB? See if we can find the roughness in here. Yeah, that's cool. Meatball, it's cool. You guys can chat. There's no problem with you guys chatting. It's all completely fine. Except for if it's about new programming languages. Yeah, that talk just gets a bit repetitive, to be fair. But anything other than that is completely cool. Oh, why not Rust? Yeah, why not? Why not? Thank you, appreciate it. Nowadays I'm staring at classes. What is an SC? I guess that's shader code. Yeah, I'm trying to look for just like where this person PBR with masking. Ooh. Just this one with a... Right. So where's the Fresnel? Fresnel. With the rough. Roughness dependent Fresnel. Oh. So it's already done it. It's this the KS. No, it's not. How different is it? What's FAB? That's what I wanted to find out. Oh, that's the BRDF lookup. Right. BRDF lookup. Right. So that would have been mixed with the... So, like the cooked torrents, you multiply the shadowing terms together. I don't know why you need to do the add though. But yeah, that's outside. So the Fresnel... So it does look actually very similar to the one above. Right. But... Yeah, it's very similar. Yeah, basically the roughness in there. Maybe we should just switch out to this roughness version eventually. I don't know. But maybe we shouldn't. Right. Yeah, so anyway, there's this for now. So for the reflection, they're all using that sort of one where you could pass in the roughness. So we'll also have a way to visualize that as well. Wait, is end of V in it? Yeah. So it's the normal on the view, so the more perpendicular it is, the more whiter it is. Because that's the way Fresnel works. Right, so we should be able to take that and drop that in there. So we have to view it in the view mode and change our roughness. And see that which would be cool. So yeah, anyway, we was halfway through writing the sample code. And then I was like, Fresnel with roughness? And I got completely distracted. But yeah, the sampler's in there. And then you want the explicit MIP level of 0. So basically, you need to do that right. So you want to reflect. That's the BRDF. Well, it's not really the BRDF. Yeah, I guess you want to say reflect BRDF equal Fresnel. Wait a minute. So you need to scale the Fresnel by this.x, and then you need to add the y in that pre-computed table. Oh, nearly there. Plug that in. So I think it's multiplied by the... Alright, where am I going? Did I close the... Yeah. Then times radiance. I don't know what C diff is. Right, diffuse color. Right, that's cool, that's cool. Right, yeah, so reflect. Yeah, just multiply that by that color. Right, I think we're in. Oh, who uses vector freeze? Right, what's this doing? Ah, yeah, I'm not passing any texture. So we need to make sure we uploaded this from the CPU. There's way too many parameters. We need to come over this and clean this all up. It will happen hopefully today, actually, if this all works pretty simply. Pre-filter BRDF. Right, so we need this passed in through two functions. It's all going to get refactored, don't you worry. Yeah. Right, one more time. Then in our tiled ray tracer, BC pre-filter BRDF. Then in our push constants, we throw this boy in here. And then we simply just make sure we set that CPU side. If not, it's going to be like, you know, null texture, and then fall over and set my PC on fire. So we want to make sure that doesn't happen. Cool. So that should be the desired change. I do. Huh? What was the error? Ooh. Oh, I need a sample texture. Damn what a wally I am. Read only means I have to read a pixel coordinate, like, and not a. Yeah. So, right, what else? What was I gonna say? I got distracted by myself. Ooh. Shoot. Right, so that's the. So you're basically pre-computing the geometry term, isn't it? Right, I'm just gonna do it silly. There we go. So the naming later. What have I done? Past me has ruined me now. What is going on? Duplicate non-aggregate type declarations are not allowed. Huh. So texture 2D. How's that happening? When am I sampling from another float 32 texture descriptor? When am I doing that? Oh shoot, it's the element type. It's unknown. I see the problem. I think at least. Should I check that in the right, sample texture descriptor. So basically, when we declare an op image, one of these boys, this float 32 times 4 is the same definition as the one. So we need to remove the element type, or maybe set the element type. I'm interested. Does the element type have to be set? Format, which can be unknown. Yeah, the format has to be unknown. Sample, yeah, it does. Right, I think I know how to fix this one. Let's get back in there. So I think this is when we do our deduplication. We're looking for an image. So right. Yeah, SPIVy type deduplicate. If it's a texture and the access mode is not equal to sample, it's a super hack. Only allows for, yeah, so we need SPIVy only allows for a unique type declaration for op image. So you can only have one with the exact same parameters. So we actually need to do another if statement here. Where it's equal to sample, we'll do this new fix. If not, so where's the key? Right, interesting. Where's our access mode? Oh, there's an intrinsic type. Yes, I guess we'll get rid of the intrinsic type. Yeah, we don't care about the image format. This one, I think. Yeah, if it's not equal to sample, excellent. So here again, super hack. SPIVy only allows for unique whatever's right, okay. All texture descriptors, all sample texture descriptors will do not use the image format field. So yeah, I don't, so set the intrinsic type to the same value for all sample textures. So we just need to remove the intrinsic type. Crying out loud. Yeah, so remove the intrinsic type, and then we just store on there. I think you just put in a, well, you just remove it, and then that'll just default it to void or whatever I think it is. I think that'll do it. If I compile that, I think we can just chuck that in. So do a release build. And I'm pretty sure this will fix it. So I'm gonna put that in the game without an engine. Third party. HCC. Oh, I was gonna press enter there. This is not an odd way to default it. Yes, hopefully this fixes it. Oh yeah. Look at that. I love it when we have these fast HCC bugs that we can just fix. And they're not head scratching. That's really nice. So let's get out of the compiler code again. So yeah, let's see if this BRDF thing works. I do want to actually make a new global. Actually, let's OR this to 1. Here's what we're going to do. We'll use the show irradiance checkbox to see how this thing looks. Yeah, to see how this change looks. So by default, it's just going to be the Fresnel roughness 1, which I guess is kind of a bit new as well, but it's cool. And then if we've got this one, it will make it with that extra BRDF thing. Oh, right. So I want to take a quick break on that, on this, and I guess it'd be a bit of a teaser for when we get back. I want to fill up this and get some more water. So we'll see the differences when we get back. So BRB just gonna fetch some water. Right, welcome back everybody. So now we're going to compare the before and after with this BRDF lookup. Oh my days. No, what is going on? Shoot. Wait, the sample type is in there. Crap. Right, so sample type. Ah, shoot, I see it now. So this sample type has to be a scalar. It has to be a scalar type. So it's actually... crap. It's easy to fix. So we actually need to remove the vector component from it. So strip out the vectoriness of the intrinsic data type so that the scalar is left to differentiate. I probably can't spell that. Differentiate. There we go. Thank you, Google. Right. To differentiate some of them. Yeah, there we go. AI will replace me. No, it won't. It's fine. It's a bit like 3D game development. Didn't replace 2D game development. There will always be room for the thing before. Always. Crying out loud, where is it? Right, so we want to keep the first 8 bits. So I don't want to make it void. Oh, for crying out loud. Get in there. So I don't want to make it void. Scalar mask. Why not 8 bits? Sorry, I was confused. What? I need the first 8. Well, yeah, 16 numbers, so it's 4 bits. Right, so need a nibble. There we go. That ought to be good enough. Chuck that in there. So if we recompile that, release build. Oh. And then we'll simply just throw that in the party folder. So that should be the fix. Recompile this. Right, the old bug came back. I masked the wrong thing, surely. I'll keep all the other bits. Keep all the other bits. Oh, we want to remove the vectory part. Oh. Right. One more time. It's still that. Stolen. Alright. So, recompile. The compiler compiles. And we run. Oh, of course there's no game in the compiler. Ah. Right. Oh. We're alive. We're back. So, let's check these balls out. One day we'll all be maids and butlers to AI until then make the best of your life. I don't know. It is kind of crazy how there's a bunch of people, you know, excited about creating the end of humanity. I guess it can go either way, right? Right, so if we toggle this, there's a difference. So that's the geometry shadowing on there. So I guess you can make them brighter by changing the intensity of the light. But yeah, there we go. Sweet. Alright, so I still write code even AIs can write better than me. I'll design my own hardware and write my own code. Nice. How do they look on white? We can change the we could change the background to the daytime. Let's go. Daytime. Alright, so this is the plastic ones with a little bit of roughness. If you remove the roughness down, that's what it looks like. But if you move into metals, they look like that. Yeah, they used to be a lot more reflective before we made that change in the before we made that change. It used to be a lot more reflective, but that already makes them a lot brighter actually. It really pop there a bit. Should we see the Fresnel with roughness? Wait, that's wrong, isn't it? Right, so when you change the roughness, the Fresnel actually goes away. Okay, it makes sense. So that sort of really bright edge will go away. Nice. That's, yeah, okay, that's cool. Then we're still kind of avoid the inevitable as overlords. Hmm. Please explain this in Cyberpunk: The Black Hole. I've not read any of the material or played the game. Yeah, I'm a bit curious on why it's so rough at the lows, though. I feel like the change that we made with this pre-filter map, it's just so blurry on the lowest MIP already. With that change that was made. I don't know about it anymore. We can turn it off and you can see the difference. Render pre-filter map. So here's that change that we made. Um, it samples from the lower MIPS, but I think it's just too aggressive. So now when we see it, see, but we've got to switch back to the night one though, because it fixed up. These are a lot more. But yeah, you're seeing like jumping pixels now, but it would just make it a little bit rougher. Then those jumping pixels go away. So effectively, we need. But yeah, I mean, look at the pre-filter map. It basically looks like a high-res one at this MIP. But as you go down the MIPS, you get this nice blurred version, and that's a big improve. You know, that's why you see these sort of lovely blurry images when it blurry ones here. The problem though is nice. The problem is that obviously at 0 roughness is too right, so how's he calculating the MIP level? Where's the number of MIP levels in this? Log 2, that divided by that. Something with rogue AI systems trying to destroy humans, and humans developing a system to block them out from human infrastructure. I remember that studying correctly, but along the lines. The system is the black hole. Okay. But they have like cybernetics and stuff. Like how's the AI just not ramming into those cybernetics? You know. Right, that's good. But yeah, so this roughness thing. I think the MIP level that it's grabbing is just wrong. And I don't know how it's grabbing the right MIP level here with this maths because I've got 9 MIPS. How does it know I've got 9 MIPS? It's not the right maths. Go back to the blog. Yeah, it does the same. Right, also multiplies it by n.l. In Learn OpenGL, they didn't do that. Where is it? Oh, they do the MIP level thing here as well. In this tutorial. Right, well, we'll look at that in a second. But yeah, when they do their shader. Oh, they do multiply by n.l. We didn't do that. Whoops. That makes a ton of sense. Right. Um, let's look. That should make a massive difference now. So end IL is obviously the normal of the surface with the direction of the light. So the closer they point to the same direction, the more the light applies to the color. What's going on? Oh, it's times 4 in it. Maybe we should go back to the night one because I was really looking at that one a lot, but I just wanted to see how this one looked. Yeah, I guess you would get a. Yeah, still gonna fizzle. Yeah, we should really go and look at the. You know what? Let's just change that over now. Let's go back to the nighttime one because that's one I was really looking at a lot recently. So this is back to the without that super blurry pre-filter map change. We see the pre-film map. Yeah, I'm liking how this one looks though, but I guess this one. We could just maybe clamp the roughness when we generate the MIP 0 maybe. But then it does. That's one way around it. Right, so I missed that n.l thing. That was super bad. But they've got some fix in here. What do they say? Bright dots in prefill convolution due to high frequency details and widely varying into intensities in specular reflections. Convoluting the specular reflections requires a large number of samples to properly account for the wildly varying nature of the HDR environment reflections. Mine are not HDR, by the way. We're already taking into account the number of samples, but some environments may not be enough of them at some of the rougher levels. Because of this, you start seeing dotted patterns. Right. Yeah, I remember seeing those dotted patterns. We see it anyway. Yeah. So I guess that solution that we had did fix it. Can you see it now? These dots. Yeah, I see it. So there's a fix you can do, which does this thing here. Resolution. Let's have a look at this. So resolution times 6 divided by pi. Yep. They got this PDF thing. See, they're using distribution GDX, but that's our Trowbridge. Right, yeah. So PDF. Right, this is different. So let's copy that and do a different version. See what we get. So we've got a resolution in there of the sample map. The environment map. that we are sampling from. Cool. I got this S1 though. Anyway. Then SA sample 1 divided by times PDF plus 0.1. Right, they add this sort of 0.1 to that as well. Let's do that as well, just in case. And then 1 divided by the other one. Yep. We'll log 2 times 0.5, then you max it with 0. So roughness is 0, then you put this as 0. That's for the first MIP level. You just always choose MIP level 0, basically. Okay. So roughness equals 0. Let's just leave that in there. Stop V. H dot V. Any order, yeah, it's fine. All right, so let's see how this changes the map. So it's going to make it, it's going to go back to making it like far blurrier. Oh. That one ain't blurry anymore. That one's way blurry. And even blurrier. Okay, so that roughness equals 0 only selects MIP 0. Maybe that has made it so it's fixed up. This one should be a little bit blurrier though. Yeah, that's... Yeah, but... Oh shoot, what am I doing? What? Alright, there we go. Let's actually take a look at the scene. I'm a bit skeptical by this change actually. So... Yeah, we're now going to start seeing dancing around because that first one is not blurred a little bit, is it? Yeah, it's good, but I think this needs to get like a 0.1 or something. So it's like a little bit of the first MIP and a little bit of the second MIP when you sample it. Or maybe we should, so let's take a look at that now. Now it needs a little bit more blurriness. Maybe do 0.5. Half of the first MIP, half of the second MIP. That's what I meant to do, I think. No. Still about the same, isn't it? Maybe it's not using this. Is roughness ever equal to 0? Render pre-filter map. Yeah, that can be 0. So it's just going to be 0. Well, we can always just hard code this to 5 and just see if it, you know, actually has a clear change, I think. Right, so clearly sampling from MIP 5 has produced something blurrier. So let's just sample from MIP 1. Or maybe MIP 2. MIP 2 is a little bit blurry though. We're getting a little bit of blur there, which is nice. So I don't think we'll get... I don't know though. But yeah, then if we go to MIP, quickly let's go to the other MIP. 1. Yeah, you'll see that one's just like way blurrier. 2. Yeah, so maybe we should go for MIP. I don't know actually, why did I close that? Let's inspect to see what the lowest, with roughness 0 basically, with a metal to see if we see any jumpy pixels. Still way too many jumpy pixels. Let's put it to 4. We saw what 5 looks like. Maybe 5 is the answer, but we've got like 9 MIPs. We kind of want it to look like a perfect reflection, but also not be jumpy. Yeah, I don't know. You're still seeing those jumpy sort of pixels though. It probably needs a bit of blur. So the type of game I'm making, it's going to be from a bit further away, so you probably want some... Yeah, Right, so... I guess that just needs to be tweaked, that number, basically. But yeah, then as you get a bit rougher, it's blurrier. Right. Right, so the reflection is in there. Ah. What did we change that? If it's fully rough. Yes, you still see reflection kind of there. Yeah, I guess that's okay. So we take a look at that map again one more time. So 0, 1, 2, 3, 4, 5. But yeah, it just gets blurry and blurry until it's like that, basically. I think that's okay. Maybe we should change this. You know, so I probably want to say base lowest or first MIP first MIP to sample at, that's what we'll call it. So we need to say like to to do, tweak this. To avoid this sort of the reflection from flickering, right? Now, we don't know about this until we have a proper camera perspective, but also yeah, also we might choose to do a different solution, so it's not worth spending the time doing that. Cool, so I think we're in a good place now with this PBR stuff. Quality wise, I think I'm happy with how this looks. Nice. Awesome. What's next is we need to clean up the code and separate the lighting from the irradiance and the, what is it called? The irradiance and the radiance maps, if you want to call them that. Hey Pete, thank you so much. Yeah, it's looking great now. Super happy. So I think what I would like to do now is clean up the code, comment it, like, so I just want to I want to sync this into my brain, what I've taken in. And I also want to do a devlog because I haven't done a devlog for the whole of the PBR stuff, and I usually do them after every stream. But this stuff has been me just learning a whole bunch of things. So I want to try and condense what I've learned into a devlog. That's the aim. So I think Sunday is the biggest stream. So we're going to try and do all of that, which would be fun. So what would I need to do? So I think in the devlog I'm just going to brush over image-based lighting, but I'll link to I'll link to post about it because it's, you know, I'll probably describe like the basics of it, but in terms of the implementation, I ain't gonna be able to describe that. But I can definitely describe this stuff though. Just got to brush up on my knowledge again and rewatch some more videos, so it's in my head. Or either the Isle of Man is going to legalize or have legalized cultivation of cannabis for export to countries where consumption is legal. They want to make raking all that money, I guess, isn't it? And also Isle of Man. That's like that little island, isn't it? Off the coast of the UK. Is that all they want to do now? Is just grow weed? Hmm. Yeah, there's so much to like tidy up here. It's going to be good though. There's so many parameters being passed in. We can consolidate that into a strut somewhere, I think. Probably improve the debugging code as well. Make it so we can visualize certain aspects of it. So when I want to reference stuff in the devlog, I think we can just show the different debugging views. Radiance, you know. Let's get rid of that show radiance checkbox. We don't need it anymore. Awesome. Yeah, they'll become rich. And then those guys will take over the world. No, I'm joking. The great empire of the Isle of Man. um, yeah. So, right. Okay, so I'll check this code in for those of you who have access to the code. You'll be able to play with it in your local machine. Yeah. Let's do some quick links. There's a Discord channel if you come and hang out. I should probably make a Twitter post about this. I should post more on Twitter. And there will be a devlog on YouTube. Subscribe there. And to the VOD channel. If you want to see the VODs, they're up there as well. But the YouTube channel should be getting a recap of all of the PBR work that's gone on. So our next be on Sunday, 6 p.m. GMT +1, where we're gonna clean up the PBR code and hopefully do a recap in that stream. If not, it'll be split over a couple of streams in the recap at least. Yeah, the main objective is to refactor all of this and make it make sense. Yeah, it's nearly there. And I guess optimize it, kinda. There's a lot of just redundant dot products, but the compiler probably fixes all that up. Right. Yeah, let's find someone to raid. France. So close. Eh. Oh. Has anyone got any suggestions? People to raid. Um. Hmm. Yeah, I'm looking for someone to raid. You got any ideas? I see no C. Or anything sensible. I'm gonna raid this guy. Although it's like solarized theme. Yeah. What? Hmm? What you chatting about, Scalar guy? Strange. In Godot, yeah, I was tempted until then, until the Godot thing, or Godot, as it's called. Godot. Yeah, Godot. Right. Have a good search weekend, everyone. I'll see you all in the next one. Yeah. Thank you for coming. I'll see you soon. Wait, where's the raid button? Oh, it's there.